Our next talk, Ian Berry from Evotec in the UK is going to talk about classification analysis of 21 million commercially available compounds.
So what we want to talk about today is some work we've done on our compound database that we have for commercially available compounds. The agenda is we're going to talk a bit about Evotec because we have to, and then we'll talk about Evosource, which is our compound database, and then we'll talk about how we've been calculating lots of properties against that, and then what we've been doing to analyze that and seeing how that's useful to us going forward. So about Evotec, for those who don't know us, anyone who's been to UTM before will know that it's we come here every year. And basically, Evotec is a research services organization. We work for a lot of the other pharma, several of whom are in the room, I think. We provide lots of different services, including computational chemistry, medchem, screening, high-throughput screening, NMR, proteomics, and more recently, compound management over in the US. So now I'm going to talk a bit about Evosource. So Evosource is our, there are a lot of compound databases out there. Several suppliers are in the room as well. The reason we have things in-house is because we've connected it directly up to our ERP system, so the chemists don't actually have to use our ERP system to order things, because they find it quite annoying, and it is. So we've given them a nice, relatively easy-to-use interface that they can select their compounds, make a request, get it signed off, and then it goes straight through to purchasing, and then they don't have to worry about it after that. And we've always had this in-house, and what we did about, 5-6 years ago is we restarted from the beginning and came up with this thing called Evosource. There are some figures down there, so we've got around 22 million compounds in here from about 218 different suppliers. The chemists can search using Marvin and all the nice ChemAxon tools and with the JChem cartridge in the back end, using structures, using our own internal IDs, by name, by formula, CAS number, supplier, etc., and things like that. So there are lots of ways that we can search against this database. One of the things we found is that, and Bob will talk about this more, is that although it was very useful for the chemists, maybe the computational chemists were using it in a slightly different way. So that's one of the things we'll talk about later. But what we can do is we can have a look and see what's in our stores as well. So we can look in our stores and in the other labs to make sure that we're being lean and everything else like that in terms of what we're buying. So we don't buy stuff if we've got it in stock already. We can create quotes so that generates a nice email that sends off to the suppliers. They probably hate the automatic emails that we send them, but they still reply, which is quite nice. And then have a view about what is available from different places. In our preferred supplier list, purchasing will give us a list of suppliers and say, well, we've got to try and order from these because we've negotiated a really good discount or something like that. But we can always look at other suppliers as well if there aren't any preferred ones. Some of the technologies we're using is the standard things: the applet, structure to name, standardizer, and the cartridge, which we're accessing through the Java Persistence API as well. So obviously, with a system like this, we have to keep it up to date. And that's probably a challenge that everyone who looks at catalogues and supplier catalogues has the problem with. But we came up with a sort of routine that we do on a very regular basis, probably far too regular basis, where we contact the suppliers. We get the information from them in a variety of horrific formats because they're not very consistent, and PDFs, Excel, sometimes SD files if they're really nice, but generally not. We work out what we've got back from them. We could basically convert them into an SD file so that we can actually process them more or less automatically. We use a lot of structure checker and the structure to name to structure tool to get it into a format that is usable. And then we load these catalogs in. And we have a kind of an XML mapping file, which is kind of a sort of ETL type process to load them in. So it's transforming the data from whatever the supplier gives us into the format that we have in the database. We try and do that in parallel, but we have found on occasion that does slow down the querying part for the users, so we try and only do loading during the evenings. And when you've got sites all around the world, we've got about a 4 or 6 hour window where we can actually do this loading. So we can get through I think someone was saying about 6 million compound catalog in about 3 or 4 weeks, which is not too bad. Obviously, the supplier catalogues aren't great, so there are always errors in there, so we have to sit and fix the errors, so it's a fairly time-consuming process to do that. And then we'll come back to the beginning and we'll have to contact the suppliers again, which is always a bit of a pain. So it's a very much a cyclical process where we're going around, contacting suppliers, getting the data in, so that the chemists can have the most up-to-date details about the compounds that are available. So now I'm going to hand over to Bob, who's going to talk about how we did some calculations on the data.
Okay, so I'd just like to show you how we added value to the EvoSource database by calculating properties on the compounds in there and then adding 2 metrics into the database, and that makes it easy for chemists and computational chemists to pre-screen the compounds and decide which ones are going to be suitable for putting into virtual screens. So first of all, I'd like to show you this. This is the our Evotec drug likeness categories. So we try and split up all the compounds into these different categories. So if you see at the start of these, they've each got a substructure search and a fragment search. So basically, if the compound passes the substructure search and the fragment search, then it will fall into one of these drug-like, lead-like, or fragment-like categories. And if not, it will fall into either the amber or red category, depending on how bad the fail is. So, and then these are further subdivided by looking at various physical properties. So this is our historical process before we put the compounds in, put the calculations into EvoSource. So what would have happened would have been that all of the structures that were categorized as screening compounds would have been exported from the database, and computational chemistry would have then set up a local Mo database and then again used Mo to calculate the properties. And then they'd have run the structural alerts on there. So the problems with those were that, obviously being in a Mo database, it was only available to the computational chemistry group. And as we're constantly adding compounds into EvoSource, then there's a backlog of compounds that have to be added into the Mo database and the properties calculated on them. And finally, when chemists were comparing the results that they were getting from computational chemistry, there were slight differences in the physical properties between the ChemAxon tools and the Mo tools. So what we decided was we were going to streamline the process. So first of all, we looked at calculating simple properties, so like hydrogen bond owners, hydrogen bond acceptors, C log P, on all the compounds in EvoSource. And for those we used the ChemAxon JChem cartridge. And after we'd run them on all the compounds existing in the database, then we set up a weekly job that as new compounds are added to the database, then these properties are automatically calculated. The only one that we're not currently using ChemAxon tools for is log S. So we're still using Mo to calculate that. So we have to call on computational chemistry to carry out the calculations for us. And just here at the bottom, just to illustrate, we've got the range of log S values against numbers of compounds that you can see in EvoSource. And then again, just showing these simple properties, so molecular weight, hydrogen bond owners, hydrogen bond acceptors, rotational bond, and log P. Just see that we've got a nice spread of properties within the EvoSource database. So the next stage was that we had to run the structural alerts and the fragment filters on all the compounds so that we could put them into the different Evotec categories. So the first step was to convert the Mo smarts into ChemAxon format. Then we added a table of structural alerts and fragment filters into EvoSource, and then ran the substructure searches on all the compounds in EvoSource, and then combined with the physical properties we'd already calculated, we could put the compounds into different categories. The main problem was that it took about 6 months to run all the substructure searches due to memory problems that we haven't fully figured out what was the problem. And so we've now got the EvoSource drug likeness categories in the database, and what we wanted to do then was to look at a new parameter that we could also use for the chemist to assess the drug likeness of compounds, and this is called quantitative estimate of drug likeness, or QED. And it's based on similar parameters to the Evotec categories, but each of the parameters is weighted from a model fitting to known drug compounds. So before we added this calculation into EvoSource, we carried out a proof of concept where we took a subset of compounds from our screening collection and calculated QED on those, and then we showed them to a panel of medicinal chemists to see whether they rated the compounds as drug-like or not drug-like. And from the results we got back from them, we could see that QED was in agreement with what they thought about the compounds. So what we did then was we set up the QED calculation for EvoSource, favouring structural alerts, and we also substituted log D for A log P so that we could consider ionisation as well. And this has now been set up as a weekly job in EvoSource.
Okay, so what we're going to do now, I mean, QED can be classed as a measure of beauty of a molecule in some cases. So what we thought we'd do, we kind of gave it away a little bit earlier when we went on too many slides, is to see if we could get a vote in the room as to whether people thought these were, the molecules we put up on the screen are beautiful or not beautiful, or in the middle somewhere and you're not quite sure. So we only got 3, so it's going to be very quick. Can I have a raise of hands? Who thinks this isn't a very beautiful molecule? Okay, who thinks this is a beautiful molecule? Pardon? Yeah, I don't know. I'm not a chemist. I don't know these things. I just go with what I think. Okay, so the QED score for this one is high, so it reckons that it's quite a beautiful molecule. How about this one down the bottom? Is that a good molecule or a bad molecule first? Votes for bad molecule. Lots of people voting bad. Okay, I think we'll give that one away. That one's there's going to be a prediction here that QED is low on that one. How about this one then? Can we have votes for beautiful? We got 1, 2, 3, a few going. How about ugly molecule? We'll call it. Yeah, a few going up there. So it's a bit of both really, and obviously just to be predictable, that comes out as a sort of medium level score in QED. So it's it's not a very scientific survey, but it's we based some of the weightings that we put on based on what our chemists say. So our chemists may be biased, of course, towards what they think is a beautiful. It's all in the eye of the beholder or whatever. Okay, I'll hand back to Bob to talk about how we analyse the data.
Okay, so I'll just show you how the QED score and the Evotec categories compare. So on the left here, we've got the numbers of compounds that fall into the different Evotec drug likeness categories. So you can see, if you count up the numbers there, you've got roughly the number that falls under the good QED curve there. Amber, roughly the same sort of numbers as in the medium compounds, and roughly the same number in the low compounds, but so a better plot. This just shows the QED scores for the different Evotec drug likeness categories. So you can see that the blue line here, the drug like category, lead-like, the green, and fragment-like are all falling in the good level. Amber is falling mainly in the middle categories, and red in the low. And then here we have a comparison between around 700 known orally available drugs and EvoSource. So here on the left we've got the plot of frequency versus QED. You can see they overlap quite nicely there, and the numbers of compounds split up here in the pie charts are very similar.
Okay, just a few final thoughts really. So for us, EvoSource is providing a very good tool for our chemists to be able to order normal building block compounds, but also now for our computational chemists to do analyses and build better libraries, virtual libraries, and eventually better screening libraries for Evotec and for all our clients. The QAD calculation that we've put in is producing a useful tool for filtering, and it's obviously other people are using it. As I point out down there that there's some of the calculations are now in the latest version of Kemble. So obviously other people are looking at QED as being a good measure of how good a compound might be. And finally, thank you to the people who actually did all the work, which wasn't me or Bob. Some people from the computational chemistry team, Catherine from the science team who did all the stuff in the database, and again, Dan from computational chemistry. So any questions? I think that is everything.
Ian, what's your attrition rate? How long are you willing to wait for a compound?
That's a good question. Yeah, it depends. Probably 2 to 3 weeks, probably maximum.
So what's your iteration?
There are certain suppliers that we try not to order from. I think would be the best.
So you kind of keep. With that, I mean, you have your preferred supplier. But I just.
Well, yeah. There's purchasing have their preferred suppliers, and computational chemistry have their preferred suppliers, and the chemists have their preferred suppliers. So there are a range of different. So we've had an argument over the past few weeks. Is should we get rid of certain suppliers because everyone hates them, and when we go, well, we might as well keep them in because they may be the only supplier of that. If we want to get a certain compound, we've got to keep them in there, and at which point we have to say to a client, yeah, you're going to have to wait 6 weeks for this to be synthesized by them, or we'll work out how to synthesize it ourselves, kind of thing.
And do you keep your curation? So when you get a catalog, you go through and you curate.
Yeah.
And then the next time the catalog comes, do you remember your curation moves, or do you have to redo it from scratch?
We will use KNIME quite a lot for that, and Instant JChem, and then the XML file that we've generated, in theory, should be still operational for the.
We run into is they change catalog numbers.
Yeah. Yeah. So you may keep it for say 20-30%. It's going to be the same every time, and that's great. It's the other 50 or 60% that are.
Yeah, it's the same compound. Do you try to use their ID?
No, we don't care.
So you try to do a structure search.
We base it all on structure, and if we expire the old catalog, and then so that gets rid of all the parts, the purchasable parts, as it were.
You kind of curate again and again.
Yeah.
That's a tough problem.
But if you start trying to match on everything, the loading process grinds to a complete halt. It's weighing one thing against the other, and it's just easier just to blow the old stuff away and load it in as fresh. Hopefully you've got the structure in there because you'll have been there from before. You don't ever get rid of the structures.
The problem is if you've gone through work and you hand curated the damn thing,
Yeah.
fixed it, and then you blow it away, and you've got to do it again.
Yeah. But if we do find problems with the catalogs, we send them back to the suppliers and say, fix your flipping catalog.
Are you lucky with that?
No. Some are better than others. Others,
Everybody's grappling with the supplier ecosystem. So
Yeah.
we've seen 3 talks this weekend, and every company across the world's doing the same thing.
Yep.
So how about moving this to the pre-competitive arena in some sense? Like the Pistoia model. Is there another way? Yeah.
there may be
Any of the suppliers in the room can make a comment as well.
there may be other ways. The reason we have it in house is that we can search privately without anyone knowing what we're searching for. So we search on behalf of other people, and B, because we've got it directly connected into our ERP system, and the chemists don't have to faff around going into that to order their compounds, which they hate. So there are a few, and there are other advantages as well. But yeah, it's a fair point, and it's something we are always looking at what is out there to make sure that we're not duplicating effort. But our thing is 2 or 3 times bigger than e-molecules, for example, and we've done an overlap search of e-molecules versus ours, and we've got everything that's in e-molecules. So why should we use things like that? I know they're not in the room, so I'm not going to be. Yeah.
Quick question.
You said you're bigger than e-molecules. Those 22 million, those are not all stock compounds.
No, that's probably true.
If you would take stock compounds, you're probably the same as e-molecules, I would guess.
Maybe a few more. Yeah, I don't know.